Hello and welcome. I'm Rachel Pownell and I'm one of the Knowledge Exchange Managers for the Southwest Creative Technology Network, or SWCTN as we like to call it. I'm a white woman in my 50s. I've got brown eyes and grey-white shoulder-length hair, and I'm wearing a black jacket and a black t-shirt. My pronouns are she, her. I'm joined on my left by British Sign Language interpreter Siobhan Green. Siobhan's pronouns are she, her. She's a white woman in her mid-30s and she's wearing a black top with puffy elbow-length sleeves. Her hair is brown and tied in a ponytail, and she's sitting and interpreting with a blue screen in the background. So this lightning talk is about the SWCTN data prototype Pollenize. The focus of Pollenize is to gather environmental intelligence data to research and combat the drivers of insect decline and deliver public-led rewilding solutions using the honeybee as a vehicle for green recovery. And I want to introduce Matthew Elms to you, who's one of the co-founders of Pollenize. He's a chartered manager, environmental scientist, and a far-out thinker. So I'm going to hand you over to Matthew now. Over to you.
Thanks, Rachel.
When I think of data,
It's a great pleasure today to be able to show you what we've been up to the last 3 months. We've been working with the Data Place, a local technology company, and we've been working with a composer called Simon Dobson. And here's a little video of our progress and where we are going. Let's play now.
we may think of data as a recent term and concept, a resource that we can collect, analyse and derive value from. Here we have the honeybee. They have been around for 140 million years. The honeybee has been using data to survive long before humans even existed or pondered its potential. Data is everywhere. It is all around us. The smallest of insects have selected useful data streams and utilised it for their own survival. They are using this intelligence quite literally to not only survive, but to thrive. The need for resource efficiency and its swift communication has been the innovative driver of their democratic survival. The honeybee is a superorganism with up to 50,000 individuals. A single colony of honeybees can visit up to 5 million flowers in a single season from a choice of 159 species of plants here in the UK. These are not just any flowers, but the flowers that have co-evolved with them over millennia. This knowledge is passed down through their DNA, and this knowledge is power. DNA has the ability to pass on this wealth of knowledge with very little parental involvement. This is nature's blockchain. Millions of years of data is compressed and transferred through DNA for creatures that only live typically for less than 50 days. Nobel Prize winner Carl von Frisch and his team researched honeybee behaviour for decades. Their discovery helped decode the waggle dance, and insight into something human beings would otherwise have no understanding of. Through the waggle dance, we are now able to begin the journey to understand bees' collective consciousness. They sense and perceive the environment in a way humans would struggle to even comprehend. Our challenge is to unravel the simple yet mysterious foreign communications bees use and rely on. But can we crack the code? Nature's processes can be ignorantly overlooked, but when studied and scrutinised, patterns emerge and lessons can be learned. Carl von Frisch cracked the code, but it's time to take the next step and automate this so that it's not just an enigma.
Hi, my name is Simon Dobson. I am a composer and a producer. My job as a creative in this project is to bring inclusivity to the project by creating a way that the data we will be producing can be more easily accessible and interpreted on a level other than figures and graphs. I have been learning and using a program called Max MSP, which is a complex musical programming piece of software which acts as an interface between the data and the sounds that will ultimately become a way of interpreting the scientific data coming out of the hives. We have chosen to work with 3 different sets of example data at this point, corresponding to what would actually be being measured. The first is traffic, so that means the ins and outs, both the frequency and the amount over time. The second would be the direction in which the bees would leave the hive to make their trips. And the third would be how far they travel to collect their nectar. And this is all data that would be provided by the decoding of the waggle downs. Each of these sets of parameters will affect each of the others. And the challenge was to work out what was good and bad for the bees and find a useful and accurate way of portraying this musically. At this stage, I've been using very basic pitch ranges, very basic rhythmic ranges, and very basic actual sounds. For traffic, low notes have been representing low traffic. The lowest notes meaning very, very little traffic, and therefore a quiet and possibly ill hive would be very long low notes. And then as we scale up through the 1 to 10 in the data, we would be then using shorter notes but of a higher octave, until at the very, very top we've got lots of very, very fast notes happening to indicate kind of very hectic in and out of the hive. In terms of direction, we will be working with an XY axis that shows a ping here for a data set saying the bee has been there, and then we're using those data points to correlate with the lowest note in the traffic data stream, so that set of data will change the pitch of the other set of data, which you can see here. The last data set will be distance, and we decided that travelling a long way is bad for the bees, they'll be tired. So a data point that shows they've collected nectar near the hive is good, so we're using warm, lush sounds for near to portray good. And then as the data points say that the bees have been getting further away, the actual sounds get much more glassy and much more sparse and much more cold. The ultimate goal is to produce music that's constantly changing, easy to interpret, and accurately represents the health of the hives. But I think at this point we've shown that we can use this data and turn it into music that can show us what's happening in the hives. Like I said, there's a lot of work to do, but I think we're on track.
I'm Lucy from the Data Place. I'm working with Matt Pollenize on the project to enable these hives with artificial intelligence. So a couple of test hive boxes here, which Matt has given me, and what we're working on is putting this, not its final form, but it will be in another case, Raspberry Pi, infrared, night vision camera, goes into the hive here. So, right, let's have a look inside the hive. So, off comes the lid. And in here, got a little window looking through. This side is our test frame. That way up. There we go. Right, one final clip. So here's a little diagram. Quite simple. 5 blocks, Raspberry Pi, infrared lights, power, and the bees.
Brilliant. Also, Lucy has been working on rigging the beehives with high-powered accelerometers, which measure vibrations inside the beehive. The waggle dance isn't just a visual component. A large part of this is the vibrational spectra that bees communicate on. But this is an area of science which is not really, that hasn't been looked into very much at all, actually. So we have been working with Professor Martin Benchik from the University of Nottingham, and he has sent us the components to rig together the system. And here's Lucy playing around with that system with the haptic feedback portion of an Xbox controller.
Just recording.
So there you go. That's our innovation process, and we are so excited to be able to put our bees into these hives in the coming weeks, perhaps even this weekend if the weather holds out. Yeah, that's where we are. And if you would like to know more about Pollenize and what we're up to, visit our website, Pollenize, POLLENIZE.org.uk. And if you want me to answer any questions, just drop me an email and I'll be happy to reply to you. Thanks for listening.